Hello students, welcome to aimsindia online classes. This is a chemist session. Here we are discussing about periodic classification. So till now we have seen how the classification of elements were done by different scientists and about modern periodic table, special names given for groups and periods in the modern periodic table, and trending of atomic properties in this new modern periodic table we have seen. So based upon this all, in this session we are going to see a practice sheet 2, which includes different kinds of questioning like multi-correct answered, comprehension paragraph, matrix matching, statement type, analytical approach. These are all kinds of questions we are going to see in this practice sheet. Let us start that now. Good. So first let us see the multi-correct answer type questions. Here each question may contain one or more than one correct answers. So read the options carefully and choose wisely. See the first question given here. Identify the coinage elements. In the modern periodic table, 1B group elements, that means first B group elements or 11th group elements are used for making of these all coins. For minting of coins they were used. That's why they are specially called coinage metals. See which are first B group elements, those will be correct answers here. See which elements are first group elements? Copper, silver, gold. These are 1B group elements which are called as coinage metals. But carbon is fourth group element which is not. Okay, only these three are correct answers. See the next one. Which of the following are representative elements? What are representative elements? The elements which are being responsible for the most of the chemical reactions are called generally representative elements. Mostly S block and P block elements are being more reactive, so they are called representative elements. S block elements and P block elements except noble gases, means alkali metals, alkaline earth metals at the left side, and at the extreme right side except noble gases, remaining 5 columns in the P block. These all considered together as representative elements. See now the elements from S block and P block whatever are there, they will come under these representative elements. Iron, we know iron is a D block element which will come under transition element. Iron is not representative element. Whereas potassium is an S block element, isn't it? So it is a representative element. Even calcium is also S block element because it's secondary group element. It is also representative element. And if you see the last one, nitrogen, it is a P block element, fifth group element, isn't it? Nicogens. So S block elements and P block elements, all they will come under representative elements. So hence these three are representative elements. Okay. Next, which of the following statements are correct about modern periodic table? So here some statements are given about modern periodic table. See first one, it has 7 periods, isn't it? Yes, modern periodic table has 7 periods only. 7 horizontal rows are there, those all together called as 7 periods. And next it is classified into 4 blocks. Yes, of course. Modern periodic table is classified into 4 blocks, namely they are S, P, D and F blocks. Next, so this is also correct statement. What about third one? It is done based on the atomic numbers of the elements. Yeah, it is also correct. Till the modern, before all the classifications which were done before this modern periodic table, they were all done based upon the atomic masses of the elements. So because of that, they have faced certain problems. So here, this modern periodic table, which was given by Mosley, is done is constructed based upon the increasing order of atomic numbers of the elements. So most of the problems in those earlier classifications were clarified in this. So it is based upon the atomic numbers. This is true. Next, noble gases are cited at extreme left side of the periodic table. Is it correct? Where are the noble gases? Noble gases are they are located. Noble gases are located or placed in the modern periodic table at extreme right side. That is in the 18th column. That also is say as a 8th A group or 0 group. but not at left side. So it is incorrect statement. What are at the extreme left side? There are alkali metals, but not noble gases, isn't it? So this is incorrect statement. Remaining three are correct statements. Right? Next question. Which of the following is correct about S block elements? See, some statements are given about S block elements here. The elements in which the electron enters the S subshell of their outermost energy level are called S block elements. Yes, this is correct statement. Actually, they are defined in this way. The elements for which the differentiating electron enters into S subshell of their outermost energy level are called S block elements. Next, this block is situated at the extreme left side of the periodic table. Yes, this is also a true statement because the S block contains two groups. They are first A group and second A group. These two are positionized, situated at the extreme left side of the periodic table, the starting two columns. So that is true. Next, this block contains elements of 1A and 2A that also given here. Yes, 1A means alkali metals, 2A alkaline earth metals. These two are present in this S subshell because for the elements in these two groups only the differentiating electron is being entered into S subshell. So this is also true statement. None of the above. So it is not correct because these three statements are correct. Right? Next one. Which among the following elements have sudden increase between second and third IP values? See, they're asking to find for the elements which are having sudden increase, greater increase between the second and third IP values. There should be, if you want they, to be there, greater difference between the second and third IP values, that element should have two electrons in its outermost shell. By that what happens? After the removal of two electrons, it attains nearest noble gas configuration. By that, the removal of third electron requires a much greater amount of energy. That is, third IP will be much more greater than second IP. There will be sudden increase between these two. When it happens? When the element, if it is having two valence electrons, for those elements, there will be gradual sudden increase between the second and third IP values. Now see here, the elements which are having two electrons in their valence shell, they will be correct answer here for this statement given. So which element will be having the two electrons in their valence shell? Generally, second group elements or second A group elements will be having two electrons in their valence shell. See the elements out of these four which belong to second group, that will be correct answer. See magnesium, it is an alkaline earth metal, second group element. What about aluminium? Aluminium is a third group element, isn't it? Because it is atomic number is 13. If you write configuration 1s2 2s2 2p6 3s1 3 3s1 sorry 3s2 3p1, totally there are three valence electrons, so it will be having a sudden increase between the third and fourth ionization energies, not between second and third. So it is not correct. If we see sodium, we know sodium is a first group element because it has only one electron in the valence shell. After loss of one electron, it will be attaining stable electronic configuration of neon. So the removal of second electron requires large amount of energy. So it will be having sudden increase between first and second IPs, but not second and third. Okay, this is also incorrect. If we see calcium, it is also a second group element. So it also have two electrons in its valence shell. So it will be also having a sudden increase between the second and third IP values. Okay, now the correct answer is these two, calcium and magnesium, because they belong to second group, right? Next one, the correct order of electron affinity. Electron affinity means the amount of energy released by an atom while gaining electron. Generally, this will be greater for small sized atoms. Now you can say in a period left to right, electron affinity increases. In a group from top to bottom, it decreases generally. But if you see the first option given here, sulfur and oxygen, both belong to same group. If any elements are given in the options to compare the properties, you should identify the relation between the elements given in the options. There will be compulsory a relation, either they might be belonging to same group or same period. In that way, if you observe here sulfur and oxygen, these two belong to same group, isn't it? So now in a group we are telling top to bottom electron affinity decreases, but we told one exception here. Because of smaller size of the second period oxygen, next third period element sulfur is having greater electron affinity than that of oxygen. So sulfur having electron affinity greater than that of oxygen. This is true. In the same way for seventh group elements also. Actually from fluorine to chlorine it should decrease because size increasing. But because of very smaller size of fluorine, chlorine is having greater electron affinity than that of fluorine. So this is also correct. Why? What happens if the size is smaller? We know if the size is smaller, there will be very less size for the accommodation of electrons. So electron affinity means the energy released while gaining electron. If fluorine gains one electron, there occurs some repulsions between the already existing electrons and this newly incoming electron. To overcome these repulsions, certain amount of energy will be consumed by fluorine atom. So the amount of energy being released out will be less than the expected. That we say as electron affinity. That is why fluorine is having less electron affinity than the expected. The two, it is less than that of chlorine. Got it? So this specially we say for p block elements, first two elements. In the same way you can see phosphorus and nitrogen also. So actually nitrogen should have greater EA value or electron affinity value than that of phosphorus. But because of smaller size of nitrogen, phosphorus is having greater electron affinity. So this also you can say true. But in case of magnesium and sodium, if you see, what relation do these two have? We know these two belong to same period, isn't it? Both belong to third period. Now in a period from left to right, electron affinity increases. So now than sodium, magnesium will be having greater electron affinity. The same it is mentioned here, so it is also true. Now what will be correct answer? Even this also will come because it is in a period they have given. Remaining three relations are in groups, right? Next one. On moving from left to right in a period, electronegativity values increases because it's given here in a period when we move from left to right, electronegativity increases. Why does it increase? Because the size of the atoms gradually decreases. If the size decreases, what happens? Nuclear force of attraction increases. That is, a nuclear charge increases. So what options they have given? See, because of decreasing atomic size. This is true. And because of increasing nuclear charge. This is also true. What are the remaining reverse they have given? Of course. Now these two are correct statements because of size decreasing and at the same time nuclear charge is being increased. Hence electronegativity increases. Next one. Which of the following are correct order of increasing electronegativity in a group? So first let us see what happens in a group to the electronegativity property. In a group, from top to bottom, atomic size increases. If the atomic size increases, electronegativity obviously decreases. Now see the relation between the elements given here. We know cesium and lithium belong to same group, that is first group. From lithium to cesium, size increases. So electronegativity decreases. Now in these two, which will be having greater electronegativity? Lithium. Okay, lithium is having greater electronegativity. This is correct. What among these secondary group elements mentioned here? From beryllium to barium, atomic size increases and hence electronegativity decreases. So this is also true. And in case of carbon family, we can say carbon to tin, atomic size increases, hence electronegativity decreases. So these three are correct statements. So the relation between the electronegativity and atomic size, if we are able to compare, we can predict these all. As size increasing, electronegativity decreases and vice versa. Next, let us say about comparison passage type questions. See the first one. The number of a period in which the given element is present is equal to the valency shell number of that element. Yes, the shell number, the maximum shell number in the electronic configuration of an element gives its period number. Okay. Now, the number of elements present in third period. How many elements are in third period? We know in the first period there are only two elements. They are hydrogen and helium. So it is called very short period or shortest period. Now second and third periods are having 8 elements in each. So they are called short periods. Now the same they are asking here. Third period contains 8 elements. Right? Next one. The longest period in the periodic table. So we told second and third periods are having 8 elements, so they are short periods. Next, fourth and fifth periods they contain 18 elements in each. So they are called long periods. Next, sixth and seventh periods they contain 32 elements. That's why they are called longest periods or very long periods. But here in the earlier it was given in our books like seventh period is the incomplete period because some elements were to be found. But nowadays, recently, they have discovered those unknown elements and they filled the seventh period also. Now we can say clearly, seventh period and even sixth period also. These two will come under longest periods because both of these two are having 32 elements in each of them. Okay, sixth and seventh periods are longest periods. Next, the subshells filled in fifth period. So if you see in the fifth period, among S block elements, S subshell is being filled out the outermost shell. So 5S will be filled. By coming to P subshell elements, that means P block elements in the fifth period. For them, P subshell is being filled in the outermost shell. If we come to middle of the periodic table, that is D block elements. For them, D subshell will be filled for the penultimate shell. Penultimate shell means last but one shell. So for them, outermost shell will be fifth shell and last but one shell will be fourth shell. So in the fourth shell, D subshell will be filled for D block elements. Okay, so 5S, 5P, 4D. These three will be filled in the fifth period. Right, all of these. Let's see here. Let us see the matrix matching type question. See the matching here. Some metals or some elements are mentioned in the column 1 and their special property is mentioned in the column 2. Try to match this. See the first one, cesium. What about cesium? It is an alkali metal. So we can say it is a metal. And there is one more special property for this. That is, it is a highest electropositive element. Because of its greater size and lower valency, it is called, it is an element with a high electropositivity. Next, fluorine. Fluorine is a non-metal halogen. It is an element with a high electronegativity because of very smaller size and greater nuclear charge, isn't it? Next, chlorine. Chlorine is an element with highest electron affinity. Instead of fluorine, chlorine is being the element with highest electron affinity. Okay. Next, manganese. Manganese is a D block metal, so it also come under metals group, and its property is it can exhibit more than one valency. That we say variable valencies. Manganese can exhibit variable valencies or variable oxidation states. Different charges it express in different compounds. So this will come under for that. Now try to match this. Observe once this matching. Cesium metal and with a high electropositivity. fluorine high electronegativity, chlorine high electron affinity, manganese being a metal, it exhibits variable oxidation states. Got it? Let's go to another matching. Here, some properties of the periods are mentioned and the elements present in that period are mentioned in the column 2. Try to match these. Shortest period. We know the first period is called shortest period because it contains only two elements, hydrogen to helium. Then short period. Short period means there are two short periods in the periodic table. They are second and third periods. Second period is from lithium to neon and third period is from sodium to argon. Isn't it? Both are having 8 elements in each, so they are called short periods. So we can say first period, second and third periods are short periods and long periods are fourth and fifth periods. Fourth period contains what are given here, potassium to krypton. It is not given, okay, no problem. And fifth period contains rubidium to xenon. And the longest period is sixth period or seventh period. Sixth and seventh periods are longest periods. So sixth period is cesium to radon and seventh period is from francium to ammonium. Now see here the shortest period is helium to hydrogen to helium. Shortest periods 2 are given lithium to neon and sodium to argon. Long period 1 it is given rubidium to xenon. Longest period is mentioned from cesium to radon. See the matching here. Observe it once. Right? Let's move to next. Statement type questions. See the statement 1. Grouping the elements having same characteristics is known as classification of elements. Yes, it is correct. The classification of elements help the study of elements and their properties easier. So both the statements are true here. What will be correct answer? It is. Next statement. The first ionization potential of aluminum is less than that of magnesium. Is it true? Yes. Because magnesium is having first ionization potential greater because let us see the statement 2 given here. The second ionization potential of magnesium is greater than that of sodium. Okay, both are different statements. Let us come back to first one. Aluminum is having single electron in its 3p subshell, whereas magnesium is having paired electron in its 2s subshell, 3s subshell. So the removal of paired electron is a little difficult than removal of single electron. That is why magnesium is having greater IP, first IP. This is true. Second ionization potential of magnesium is greater than that of sodium. No, because after the removal of one electron from magnesium, it becomes Mg plus, which contains one more electron in its 3s subshell. Whereas if you see for sodium, it has only one electron in its 3s subshell. After removal of that, it becomes Na plus, which has noble gas configuration. So second IP will be much greater for sodium plus, but then Mg plus. So they have given in the reverse way. So it is a incorrect statement. What will be correct? Statement 1 is correct, statement 2 is incorrect. Okay, next one. See the first statement. More active metals are on left side of the periodic table. Is it right? Yes. At the left side of the periodic table there are alkali metals which are highly reactive metals. This is true. Even second group also alkaline earth metals which are also more reactive. This is true. Next one, inactive elements are on extreme right side of the periodic table. This is also true because inactive elements which are called noble gases, they are located at the extreme right side of the periodic table, isn't it? In the zero group. So both the statements are true. Now this will be correct answer. Next. Statement 1. Electronegativity increases in a group from top to bottom. Will it increase? How will be related to size? Electronegativity is inversely proportional to size of the atoms or atomic radius of the atoms. We know in a group from top to bottom, atomic radius or atomic size gradually increases. So if the size increases, electronegativity will be decreased. but they mentioned here as it increases, which is wrong. It decreases, isn't it? Next one, reducing power decreases on moving down the group. What does it mean by reducing power? Let us see first what is reduction. Reduction means gaining of electrons. Reducing power means the power to reduce others. So how they can reduce other elements? One element can reduce the other element by giving electrons to the other element, isn't it? So that the other element will be reduced. This becomes now reducing agent. The element which can lose electrons easily will be a good reducing agent. Now you see in the in a group from top to bottom which element can lose electrons easily, the element with greater size. We know in a group the bottom element will be having greater size. So the bottom elements will be much having much reducing power. So we can say in a group from top to bottom reducing power increases, but they mentioned here decreases. Reducing power means tendency of losing electrons. Tendency of losing electrons increases as you move from top to bottom. So it increases but not decrease. So we can say both the statements are incorrect. Right? Next one. See the statement 1. Block elements are hard, high melting metals showing variable oxidation state. This is true. Statement 2. Block elements form colored complexes, means they form complex molecules which are having different colors and have high densities. This is also true about block elements. Both are correct statements. Next, statement 1. Non-metallic character increases across a period from left to right. Will it increase? Yes, if you see in a period from left to right, metals to non-metals they turn up. So at the extreme right side, non-metals are there. Now we can say non-metallic character increases in a period. That is true. Next, a more electropositive element has less metallic character. Is it true? Electropositive element nothing but metallic element. More electropositive means more metallic. But they mentioned here less. It is incorrect. Now, 1 is correct, 2 is incorrect. Now, let us see analytical type questions. See the first one. The highly electropositive elements are good. Highly electropositive elements means the elements which can release electrons very easily. If they are able to release electrons, they give them to other elements and hence the other element will be reduced. So, which element can release electrons very easily, that is a good reducing agent. So the highly electropositive elements are good reducing agents. Okay. Next one. In which group all the elements do not have same number of valence electrons? So generally in the modern periodic table, all the groups contains elements with the same number of valence electrons. If you see first group alkali metals, all the elements in that group will be having same number of valence electrons, that is 1. In the similar way, almost all the groups in the same way, they have elements with the same number of valence electrons except one group, that is noble gas group. In these noble gases there is a helium along with the neon, argon, krypton, xenon and radon, isn't it? Here if you observe the valence electrons in helium, there are only 2 electrons in its first shell, in the 1s subshell, because its configuration is 1s2. Whereas if you observe the remaining elements except helium, for those all there are 8 valence electrons. If you see neon, its outermost configuration is 2s2 2p6. So there are 8 electrons. In the same way, for the remaining all elements also except hydrogen, they contain 8 electrons, but helium has only 2 electrons. In this way, the elements in the 8th 0 group or 8th A group do not have same number of valence electrons. Okay, next one. I1 and I2 of magnesium metal are mentioned here in kilocalories per mole. The energy required to convert magnesium into magnesium plus 2 ion. So to convert magnesium ion into magnesium plus 2 ion, 2 electrons to be removed from magnesium. First 1 electron will be removed. For that this much amount of energy is utilized. For the removal of second electron, this amount of energy required. So totally to convert magnesium into magnesium plus 2 ion, the sum of these two energies will be utilized by magnesium. What will be that? 526 kilocalories per mole, and it is in the two options. Observe here the symbol also. The energy required by the atoms will be mentioned with a positive symbol or without symbol, and the amount of energy released by the atoms will be mentioned with a negative symbol. So this represents a exothermic reaction. This positive symbol or no symbol represents endothermic process. We know ionization potential is endothermic because it is energy absorbed by the elements while releasing electrons. Right? So here B will be correct answer. Next one. According to Mulliken, electronegativity of an element is equal to. So electronegativity is equal to the average of the ionization potential and electron affinity of an element. So where it is here, IP plus EA by 2 gives the average of those two, which is equal to electronegativity of an element according to Mulliken. Next, for an element, IP2 will be more than that of IP1. For all the elements, generally second IP will be greater than that of first IP, and third IP will be greater than that of second IP. So this is due to effective nuclear charge increase. As number of electrons are lost by the elements, effective nuclear charge increases. Because of that, IP values will be gradually increasing, where it is given here. Right? So the next one, among sodium hydroxide, potassium hydroxide, lithium hydroxide, and cesium hydroxide, the strongest base and weakest base are respectively. Observe once the metals in these hydroxides, there will be a relation. So compulsory there will be relation when they ask to compare or to find out the maximum or lower. Lithium, sodium, potassium, rubidium, cesium. What are these elements? These all belongs to same group, that is alkali metals. So alkali metallic hydroxide they have given here. So in a group from top to bottom, basic character increases because metallic character increasing. So from lithium to cesium, metallic character increases and hence basic character also. Now which will be the strongest base? Cesium hydroxide, which is at the bottom. Cesium hydroxide is the strongest base, and the topmost one, lithium hydroxide, is the weakest base. They asked first strongest. So first cesium hydroxide and then lithium hydroxide. Where are these? Here. Okay, this is correct answer. Next one. According to Mulliken, electronegativity of an element is given by. Yes, he assumed that electronegativity is also having the tendency just like the electron affinity and ionization potential. It is also being influenced by the properties which are being affecting these two properties. That's why he taken the average of these two properties, ionization potential and electron affinity. The average of these two he considered as electronegativity of that atom. Where it is mentioned here, average of ionization potential and electron affinity, which is equal to electronegativity of an element. Okay. This is about practice sheet 2 of periodic classification. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.